The low-frequency seismic technology. On the Earth's surface and in its interior, there is a constant background microseismic noise, the origin of which is inextricably linked to the processes taking place in depths of the Earth, atmospheric pressure fluctuations, behavior of the oceans, solid tides, earthquakes, as well as human activity. The specific features of the background microseismic noise include a wide frequency range, low energy level, and unknown location of sources. To record background seismic oscillations when conducting surveys, highly sensitive low-frequency 3-component seismometers characterized with a very low noise level are used. Such seismometers are much more sensitive to weak oscillations if compared to standard seismic equipment. Therefore, they are able to clearly record the microseismic background, especially in the low-frequency range. The layered geological environment is a kind of filter for wave processes that generate the background microseismic noise. Therefore, an amplitude-frequency response of the medium reflecting the geological section at the measurement point can be obtained at any point on the Earth's surface.
Это удивительно.
This is really amazing because the analysis of the natural oscillations of the Earth's surface can help identify the presence and location of oil and gas deposits. Based on this fact, in the early 2000s, Gradient developed a technology for hydrocarbon deposits prospecting and exploration and called it low-frequency seismic sounding, or LFS technology. The fact is that the oil and gas deposits are an anomalous zone in the low-frequency range, which has increased absorption at low frequencies. The reason for the absorption is a multi-phase structure of the deposit, consisting of a rock skeleton and mobile phase, oil and gas. As a low-frequency wave passes through, the mobile phase appears here and there in the fractured porous rock skeleton. During this process, the internal friction leads to the wave energy transformation into thermal energy, causing absorption. The contrast of absorption from the thin layer results in an anomalous reflection from the hydrocarbon deposit. This effect is almost never observed in the case of water-wet formations, since the differences between the physical properties of water and the rock skeleton are insignificant. Microseismic investigations based on the low-frequency seismic sounding technology include the whole range of works from field observations to data processing and interpretation. When conducting a field survey within the boundaries of the survey area, the recording equipment is placed on the ground as a uniform network. The natural microseismic background is recorded at each observation point for about a day or so. Autonomous hardware complexes include GPS modules with time synchronization and Wi-Fi data transfer modules and can be installed in almost any surface condition. The low-frequency seismic sounding technology was successfully tested in the shelf sea areas and the transition zones. To perform works on the shelf, automatic self-floating nodes are used consisting of a 3-component low-frequency seismometer and a hydrophone in a sealed case, as well as an automatic floating system triggered by a command from the surface or automatically. A comprehensive range of equipment operability and records quality control activities is conducted during the field survey. The field observation records obtained are transferred to Gradient's Analytical Center to perform office works. In the office, the field data processing, the full wave numerical simulation, and further interpretation are performed. After, the final report is submitted to the customer. Field signal processing is aimed at filtering and accumulating the spectrum of vertically directed longitudinal waves. It is important in this respect to reduce the influence of Rayleigh waves from local noise sources. The spectrum accumulated in the observation point is considered as the amplitude-frequency response of the medium. The data is interpreted using Gradient-developed complex of full-wave 2D and 3D numerical modeling of microseism propagation in the geological environment. which enables forecasting the nature of the microseismic wave field for given seismic conditions and comparing the calculated model spectra with the observed accumulated spectra. The simulation is performed using a supercomputer built on the basis of graphics cards. To perform full-wave numerical simulation, a seismic mechanical model is built based on reservoir velocities using the vertical seismic profiling and structural seismic survey data. Then, a deposit in the form of a layer with reduced velocity and increased attenuation is introduced into the model at the expected depths. Once the original model spectra are obtained, they are compared with the spectra near the wells with known oil content. The similarity of model and real spectra is achieved by the matching of model properties. Once data has been collected and results interpreted, the customer is provided with maps reflecting a forecast of the oil and gas potential of the survey area, with reference to the target horizons, as well as recommendations for drilling deep wells. The use of low-frequency seismic-sounding LFS technology in combination with a traditional seismic survey and data on the oil content identified in previously drilled wells makes it possible to detect and delineate hydrocarbon deposits, assess the oil and gas potential of the survey areas, select the optimal sites for well drilling, and ultimately reduce the risk of drilling dry well as maintaining a high level of deep drilling efficiency. Actively developing the LFS technology, Gradient continuously expands the range of tasks and issues it can address and the scope of its application. The technology is successfully used to solve technological problems in oil and gas fields, such as monitoring of abandoned wells and industrial effluents, to control the formation of man-caused gas accumulations and detection of inhomogeneities in the section to reduce the risk of accidents when drilling new wells. The technology offers such main advantages as environmental friendliness, as no explosives, vibrators, chemicals or well drilling are used in the course of the works. Possibility to perform the works in hard-to-reach areas. Quick implementation and possibility to detect non-structural deposits. The high efficiency of low-frequency seismic sounding technology is proven by the results of its application at the license areas of leading oil and gas companies and is further confirmed by customer feedback. Based on forecasts obtained using the technology, more than 150 deep wells have been drilled with the efficiency exceeding 85%. Among the things Gradient sees as priorities, there are scientific validity and transparency of the developed and implemented technologies, which is supported by constant publications in peer-reviewed scientific and production journals, as well as participation in geological and geophysical conferences.